Hello, everybody. Today we're going to talk about 6.7, which is the fundamental theorem of calculus and definite integrals. So one, we're going to learn kind of how to use an antiderivative. We're going to learn some basic antiderivatives for powers and sine and cosine, I think is the focus for today's lesson. As well as we're going to match it with the idea of the fundamental theorem of calculus and learn how to evaluate an integral by hand. Okay, so that's kind of the goal for today's lesson. So an antiderivative, right? An antiderivative of a function f of x is the function. I normally denote the antiderivative as the capital F of x, whose derivative would then be lowercase, right? So I can make the relationship, or I like to write the relationship of the derivative of capital F of x is lowercase f of x. Okay, so capital F denotes the derivative, the antiderivative of f of x. All right, so let's take a look at this relationship. You know, if f of x is 3x squared, then the derivative would be 6x. All right, so if you work backwards, if I were to change some notation, let's say g of x is 6x, I could say that capital G of x is a 3x squared, right? So if you work backwards, normally what I do is I just make it capital. All right. Now, notice I didn't put a derivative. I didn't put a prime on my g, which is why I changed it to capital G of x. So just learning some notation here. So let's talk about how to do the integral of powers. And ultimately, derivatives and antiderivatives, I mean, their names are very telling, are inverse operations of each other. So for power rule, if I was given the function f of x equals x to the n power, the derivative, I would drop the power, and then I would lower the power by a full degree, right? Subtract 1. So you can see these steps here. So what I'm going to do is, if I want to do the antiderivative, I'm going to do the exact opposite, in the exact opposite order, right? So I'm going to start by raising the power, and then I'm going to divide it, right, by whatever that power is. Okay, now normally the way I like to write it is I multiply by the reciprocal, right? Raise the power and then multiply by the reciprocal of whatever that new power is. So add 1 to the degree and then multiply by the reciprocal of the new power. Okay, so those are kind of our steps. So let's kind of put this in action. Let's see if we can do some antiderivatives of some basic power functions. Okay, so I have f of x equals x squared. So I'm going to use good notation. So the antiderivative would be a capital F. I'm going to raise it to the third power, and then I'm going to multiply it by the reciprocal. Now, here's something that the notes don't go over yet. At the end, I want you to put a plus c. Whenever we find the antiderivative, we always need to put a plus c at the end of our answer. Okay? The reason being, so I want to show you, the reason being is if I check this, if you take the derivative of capital F of x, right? So if I take the derivative of 1/3 x cubed plus c, okay? The derivative of capital F of x is just lowercase f of x. And if I take the derivative of 1/3 x cubed, well, if I drop the 3 down, 3 times 1/3 is 1, x, lower the degree, and then the derivative of the constant is 0. So I get x squared. So that works out, that checks off. But you must put this, whenever you find an antiderivative, we have to put that plus c. Okay? So let's do the same thing again. All right, so I'm going to switch colors here. I'm going to use red. I'm going to say, now, before I go into any antiderivatives, let's write these all as powers. I'm going to call this 6x to the negative 3 minus 1. Okay, Now, the other thing I might do here is this 1 is kind of like x to the 0, right? So if I raise this up, so if I take the antiderivative, all right, I'm going to say x to the 4th, and then I'm going to multiply this 5 by the reciprocal of 4, which would be 1/4. So that's how I get a 5/4 in front. Now, if I raise up x to -3 a power, well, now it's just going to be -2, and I'm going to multiply 6 by the reciprocal of -2, which would then give me a -3. Now, over here, if I raise up x to the 0 to the 1st, the reciprocal of 1 is still 1, so I still have a -1, and then plus c. So my antiderivative would be a 5/4 x to the 4th minus 3x to the -2 minus 1x plus c. Okay? This would be my final answer. All right? Let's do one more. Again, I like to start by writing these all as powers. So x, the square root of x is x to the 1/2 plus 3x to the -1/2 because it's in the denominator. So my antiderivative, I'm going to raise up my power a full degree, which makes it 3/2, and then I would get the reciprocal in front. Plus, now if I raise this up a whole power, it's now x to the 1/2. The reciprocal of 1/2 is 2, which will give me a 6. So I get, now I ran out of room, but I have a 2/3 x to the 3/2 plus 6x to the 1/2 plus c. That is my antiderivative, okay, of my function. All right, so that's kind of how I take the antiderivatives of powers. Okay, now the other one, right, are sines and cosines. So if you take the antiderivative of sine, my thought process is the derivative of what is sine? Well, the derivative of cosine is a negative sign, right? That's not good. I want it to be a positive sign. So I need to take the derivative of a negative cosine of x. It would give me a negative times a negative sign, which is sine of x. So the antiderivative of sine is a negative cosine plus c. And you can check that because I can take the derivative of it and it should get me back to the original. Now the antiderivative of cosine is sine of x plus c, right? Because the derivative of sine is cosine. Derivative of the constant is 0. Okay? Now, I'm going to show you how to, using those, we're going to incorporate those. I'm going to show you how to evaluate a limit or an integral by hand. Okay? So if f is continuous on the interval a to b, the area under the curve is given by this expression. So the way we evaluate this expression is I'm going to take the antiderivative of b minus the antiderivative of a. So always the upper limit minus the lower limit. Okay? So always the upper limit minus the lower limit. So if we were to evaluate these integrals, okay? So I first want to take the antiderivative. So the antiderivative of 4 is 4x. Why? Because the derivative of 4x is 4, so we're good to go there. If I have a -6x, well, I'm going to raise that up a power, so it's now going to be squared. If I multiply that 6 in front by the reciprocal, that's just going to give me a 3. 6 times a 1/2 is just 3. I am going to put a plus c, but you're going to see in a second that I don't really need that. -2 to 5. So if I plug in 5 now, I have 4 times 5 minus 3 times 5 squared plus c minus 4 times a -2 minus 3 times -2 squared plus c. And when I evaluate this, I get 20 minus 75 plus c minus a negative 8 minus 12 plus c. And what does that give me? A negative 55 plus c minus a negative 20 plus c. Now, if you notice, when I subtract these, let's be careful of our signs here. I'm going to get a plus 20 minus c, and you can see the c's cancel. So I get a negative 35. Now, this is what we call a definite integral. This integral that we had is defined, okay, with limits, with an upper and lower limit. Now, when that happens, you don't really need to put a plus c. So if you're dealing with an integral that is defined on the upper and lower limits, you don't really have to put a plus c because we always know they're going to cancel out at the end. But if you up here, notice how these integrals are not defined. This is called an indefinite integral, okay? And the indefinite integral just finds the antiderivative. And in that case, we do need to put a plus c, all right? But at the end of the day, I know the area under that curve. So if you were to do all the rectangles from -2 to 5, you get an area of negative 35, okay? So let's do it again. So I'm going to start by writing these as powers so you can see how I work here. All right. And if I raise this up, so my antiderivative is going to be x to the 3/2 with a 2/3 out front minus x to the -1 with a -1 out front, which would make it plus 1, x to the -1, plus c. Now, if you didn't put the plus c, that's okay, because again, we are working with a definite integral, so that c wouldn't make a difference. We know it's going to cancel out at the end. So now I'm going to give myself a little room here, 2/3 times 4 to the 3/2 plus 1 times 4 to the -1. I'm not going to put my plus c because we know those are going to cancel. My lower limit is 2/3 times 1 to the 3/2 plus 1 times 1 to the -1. So let's see what I get here. 4 to the 3/2 is 8, so I'll have 2/3 times 8 plus 1/4 minus 2/3 times 1 is just 2/3 plus 1, right? So let's combine this all together. I get a 16/3 plus 1/4 minus 2/3. So let's get common denominators. Oops, not 2/3. 2/3 plus 1 would end up being a 5/3. I'm going to make all my denominators 12. So if I multiply, I get 64/12 plus, multiply this, I get 3/12 minus 20/12. And that gives me 47/12. And that would be my final answer. That's the area under the curve. Okay. So let's do one with trig. Same idea. So if I take the antiderivative of 4 sine, well, using the properties we learned in the last class, I can take that 4 out front. And the antiderivative of sine is a negative cosine. And I want to evaluate that from 0 to pi/2. So I'm going to do a -4 cosine of pi/2 minus a -4 cosine, you have to be very careful with your negatives here, of 0. Right? So cosine of pi/2 is 0, so that works out nicely for us. Cosine of 0 is 1, So I get just a -4. So my answer, the area under that curve, is 4. Okay? And that would be my answer. Let's keep going. Let's do more. So I give you the derivative, and f of 1 equals -2. Well, now in the last lesson or earlier, we had discussed about if I want to find f of 3. Now I want to pay very special attention to how I set this up. I'm going to take f of 1, okay, plus the integral from 1 to 3 of f prime of x dx. Okay, so notice this is what I know, right? They gave me this value. So that's where I start. So that's also going to be my lower limit. And then where do I want to find the area 2? 3. So I already know f of 1 is a -2 plus. Now, if I evaluate this integral, the antiderivative of f prime is just f from 1 to 3. Okay. Now, we know what f prime is, right? So if f prime of x, let me go back a step here. From 1 to 3, we know f prime was x squared minus 2 dx. So I want to do a -2 plus. Now the antiderivative would be a 1/3 x cubed minus 2x from 1 to 3. And we're only evaluating that for the integral, not the -2 that's out front. Okay, so I have now a -2 plus, if I plug 3 in, I have a 1/3 times 3 cubed minus 2 times 3. And then I'm going to plug a 1 in. Right? And I'm now just going to reduce. So I get 27 over 3, which is 9, minus 6. And then over here, I have a 1/3 minus 2, which would be a -2 plus 3. What's that going to be? Minus, this would be, let's get 6 over 3. So I need to see a little bit more. So I have a -2 plus 3 plus 5/3. So again, if I get common denominators, so I get a -2 times 14 over 3, or a -28 over 3. So that would be my answer. Okay? So if I want to evaluate for a specific value, start with the value they give you, and then integrate from this x to the x that you want, and that will tell you the location of the point that you would like to have. Okay? Okay, now there's some practice here. I'm going to post the answers to this practice online so you can see it. All right, but you can go through, you can practice taking your antiderivatives and then evaluating for upper and lower. And then, of course, there's some test type questions that are multiple choice, and you can kind of take a look at those and see what you need to do. Okay, so oops, I am going to stop here. And then if you have any questions, just email me and I will see you soon. Bye, guys.